Okay, thank you very much. We'll move now to next presentation. The title of the presentation is Making Sense of Marine and Maritime Processes Through Intelligent Information Acquisition and Sharing. And the speaker is Ioannis Kyriakides from University of Nicosia in Cyprus.
Thank you. Perfect. Hello, everyone. Thank you for all these wonderful talks, very informative and interesting discussions. My talk today is about making sense of things. That includes acquisition and processing. And my specialty is signal processing, so I'm going to start with lecture style of explaining the method. And then I'm going to talk about two funded projects, and then another bigger funded project, which is actually for the creation of a new center of excellence in Cyprus. And we all would like your collaboration on making this better. So let's go down or up. Down doesn't seem to work. Maybe I can use just this. Okay, there you go. So we have many challenges in this age, many new problems that are intensifying, and also we have to operate in a very challenging environments that are big and also very complex. Also cyber-physical, but of course the maritime, as you know, is very complex. And we need a lot of data and new methods of data processing, but also all this technology that we can employ to understand the maritime environment. And as I said, I'm going to start a little bit, not to go into too much detail, but this is for those who are interested to ask questions later or discuss. What we deal with is again, understanding what is happening by taking the prior information that we have, combining it with measurements, and understanding in terms what's happening in terms of estimates and also predictions of what's going to happen in the future. So for those who are dealing with these methods, this is a Bayesian method, but also it employs an agile method of minimizing a certain cost function, for example, minimizing the root mean squared error of an estimate. Of course, as you see there, this doesn't work really because we're dealing with highly nonlinear scenarios and heterogeneous sensors. So you won't be able to solve these equations analytically. So what we do is employ nonlinear models, use non-Gaussian distributions, and then deal with the problem of heterogeneous node configuration and data fusion. So not only fusion of data from different heterogeneous type of sources, so how do you optimally combine radar, image, acoustic data, how do you do that mathematically and without losing information, and then how do you coordinate your assets in order to get the best information possible from your environment? For example, if you have a robotic sensor, how do you do the path planning? If you have also a buoy with an acoustic node, how do you use that information to guide your robot? And also, how do you do, for example, agile sensing in terms of steering your beamforming or configuring your radar waveform? Or how do you know when to switch on and off your sensor? Preserve energy and be able to last longer in an environment where you don't have power availability. So the way we do solve this is using sequential Monte Carlo methods. And what we are trying to do here is to understand, to estimate a certain or predict a certain state, which can be the position of a vessel or a robot, or it can be some parameters in your marine environment that you are trying to estimate. So this is the state represented with these dots here, and these are various possibilities of where the ship can be, or what is the value of your estimated variable. So if you have a model of how this model, this variable is evolving across time or space or anything else, then you can predict what's going to happen in the future. So this is just a hypothesis of what's going to happen in the future. What do you do next is trying to measure different variables in order to understand which of these hypotheses are more correct than others, and build your probability distributions. But what happens when you have multiple sensors that look very different, and data that look very different from one another? Like I said before, acoustic data, image data, radar, and all that. So you cannot go back from the measurements to the state. If you look at the nonlinear and the heterogeneous data, what you can do is go from the state to the measurements. So you can map your state to the measurement space of the sensor that you have, and then understand which part of this measurement space is relevant. To give a simple example, you can understand from a prediction where a moving vessel, for example, is going to appear in an image that you have, so that you don't have to process the entire image, but only process part of the image, because you have some information from an acoustic sensor that a certain vessel is in a certain area. Why is this important to that use path planning? You can tell your robot to go in a certain direction. It cannot go everywhere, so you can save resources and power. And of course, you cannot have too many sensors, enough to cover the entire marine and maritime environment. So this method is going to tell you exactly. I left the slides there for those who are interested to go through these methods. This can be used for radar, for example, configuring a certain radar that you are transmitting in order to get the right information that you need at the moment. These are those for those who are interested in radar, and also to show a demonstration of a video of tracking vehicles in the road. The same method can be used for maritime vehicle tracking, for example. And this is not just image processing and deep learning, these new deep learning methods, but it's a 3D tracking of what's happening in a certain environment, combining video. It could be also combining acoustics or radar measurements. So this method that using, and this method is able to coordinate systems in order to act and get the information that they really need from their environment. The next part of the talk is on a certain funded project that we have that deals with these intelligent systems, and one of the methods that it uses is a method that I have mentioned before. This is MARISense. The acronym is the Maritime Cognitive Decision Support System. And as the title explains, this is about understanding what is happening in the marine environment, maritime environment, and also providing decision support to humans so that it promotes the synergies between humans. It's also cognitive because it can understand what to do in order to bring the best information. The people, is it breaking? It's breaking a little bit. If it doesn't fix, I can just move it and speak a bit louder. So please let me know. So it's cognitive because it can understand what it should do in order. Okay. It can understand what to do in order to preserve resources and also bring all the information that is needed and not something that is not needed, basically. It's the same way that humans do. We focus our attention on certain aspects that we are interested in. So this is very important for different activities. For example, for maritime and coastal tourism activity, which is very important for Cyprus. It can allocate resources in a very resource-constrained environment, such as a small island Cyprus, having so many tourists. Emergency response and planning, and also maritime spatial planning. So the idea here is how to allocate in such a small congested environment so many activities such as aquaculture that I will talk about later, and shipping and all these activities. So this is beneficial, of course. We're interested in sustainability, sustaining the natural environment, understanding what is happening so we can assess our impact. Tourism, as I have mentioned. Transportation and shipping. Cyprus is a major shipping hub, and it has a lot of activity. So we have to work around that activity to create new activities. And also coastal infrastructure is very related to the maritime environment. Energy. And as I have said before, we have a large maritime environment, very complex, and we have all these nice drones and gliders and all these sensing assets, but we cannot have them everywhere. We have constraints in our resources. So how do we make informed decisions with such limited assets? So this funded program is creating software for maritime, and also it creates hardware. We're building a maritime laboratory that initially was envisioned to be in a certain area just for testing, but now it's distributed in many locations in Cyprus. And also we're building a strategic partnership, and we would like your collaboration. And we're working towards an innovation hub. Since then, many innovation hubs popped up, and we're working with other organizations in supporting startups. And as I said before, it's focusing on three main pillars: maritime activities planning, for example, tourism, emergency response and planning, and maritime spatial planning. Cognitive fusion is what I have mentioned before, understanding where to focus the resources and fuse heterogeneous data. And an example of intelligent allocation of data is given by this path planning example that, okay, the video didn't start, I have other videos later. So how do you allocate, for example, this specific scenario is underwater gliders. So how do you do the path planning for underwater gliders so that they arrive at the same location as they started from, and also use their battery, their energy supply to actually come back, facing all these sea currents and trying to understand some uncertainties, basically, where you have more uncertainties in some places and not in others. This is a very complex problem that only an intelligent system can do. And it can actually provide, this intelligent system can provide various options for the human operator so that the human expert can choose the best path plan according to some additional expertise that the human has and the machine doesn't have. So it's about collaboration and synergy and not replacing the human factor. We have a very rich consortium that includes the quadruple helix, academic enterprises, representatives of the public, and also the government through the Ministry of Defense. And as I have mentioned, due to lack of time, I'm not going to go through exactly all the details, but we have the software, as I have mentioned, cognitive fusion, optimization to understand how to allocate your resources and understand what measurements to take in order to solve a complex optimization problem, such as where to allocate aquaculture, for example, when you have also shipping activities and all that. What measurements should we take to solve the optimization problem in a better way? We have methods that can provide this information. We are working with partners in the consortium in swarm intelligence, so using reinforcement learning to guide a swarm of vehicles so that they can make the tactical decisions, where the strategic decisions can be left to a human operator. We have data-driven modeling, which is very important in getting more accurate models so that you can map your state into that measurement state that we have mentioned before in a more accurate way. So the way to do this more accurate modeling, less errors, better accuracy is to employ physics, but also use data. So both data can be too little to provide all the information that you need, but also the physics, the way that a vehicle moves in the sea, for example, can provide the rest of the information so that you have an accurate model. We have the visualization pipeline that we're developing so that, again, about this synergy. So intelligent systems make decisions, do actions, but sometimes we don't know exactly why they have taken this decision. So it's very important to be able to provide these visuals to the human operator so that the human can also provide an input and question a result, an outcome from a certain system. And also, how do you combine all these things? We have one partner that's doing the interoperability aspect. So this handles all the data, different types of data, and also different types of systems that are put together. And also trying to explain to each of the partners how to collaborate together so that their systems work in synergy. And also we have the very important GIS, where we map all the assets that we have and all the data into a map visual interface that provides information to users. And we have gotten a lot of feedback from users, from the Ministry of Defense or other search and rescue authorities that told us we're all about simplicity. We would like to get simple information, not these complicated algorithms and all this data. So we're trying to make it for the operators, for the end user, as simple as possible so that they can make informed decisions. For our maritime laboratory, we're building buoys, an autonomous system in collaboration with a new CMMI, as I will show later, and a smart float. And also in simulation, we cannot build all these vehicles with this level of funding, but we can do simulations of swarms, and eventually we would like to combine, to create a virtual scenario that has a physical part too. So some vehicles can be actual physical vehicles, where the rest can be virtual and running in the simulation mode. And of course, we are interested in collaboration. We need the input from everyone in order to be able to collaborate and get things done. History has shown us, as we have seen in the previous talk, that we need to try to collaborate, as these conflicts do not bring anything but disaster. So we're all about synergies of collaboration and sharing information. And we have, again, as I have mentioned before, working towards supporting anyone who would like to do a startup and get some information from us, transfer the knowledge and help new startups to support the economy and bring more sustainability. We are also very interested in applying, we're doing some experiments, but we need more collaboration and with others, especially abroad, to try our systems or algorithms into different environments. So anyone who is doing actual experiments, and I'm sure many people here, as we have seen, are doing that, we would like to collaborate with you and demonstrate and validate also our findings. You see here, and Elias will appear in the afternoon. This guy that you see there is Elias Alexopoulos. He's going to give a tutorial in the afternoon. We are working into creating maritime IoT, for example, a hydrophone IoT that is very agile. What you see here is a Raspberry Pi version, but we are designing our own custom hardware also, and the idea is to be able to switch on and off when you need to hear anything specific, or classify already on board, so edge processing, classify on board if it's a ship passing or a robot or a certain type of robot, so that you can transmit only the information that you need. So if it's something that is not needed by other sensors or the fusion center, as we call it, you don't need to transmit it and waste energy unless it's really needed. We're designing a smart float. So this is the initial stages that we are in Cyprus. This is important for us. I'm sure for many people here, this is very easy to do, but in Cyprus, we're developing this new research and innovation capacity of designing our own robots. So this is the new design that we are thinking about. And also we already built this smart boat in collaboration with the CMMI. Here I show some demonstrations of algorithms. And let me see if this video is going to work. There you go. Okay. So again, as I said before, this is not just YOLO for these people who deal with this. This is 3D tracking of multiple targets, as we call them, multiple vessels at sea. And this can be a combination of image data, but also radar or acoustic data that you can get from the environment. And a demonstration of cognition and acoustic data will be shown in the next example. In this example, this is purely simulation at this point, but hopefully, as time goes by, we'll be able to do this in practice before I start the video. To explain, this is a coastal area in Cyprus. And the idea here is that you have some acoustic sensors that are very inexpensive. You deploy them in a certain area. And these acoustic sensors get detections or even classifications of different vehicles that you are interested in. And this information comes inexpensively, relatively, but also not as accurately as we would like. So in case there is a need, and we are really interested to see if something is happening in a certain environment to protect critical infrastructure or marine protected areas and all that, if we get a certain alert and the system feels that a human operator should act, a human operator, as we said before, it's all about simplicity. They can just click on the map, and at the point where they click, a drone can fly and check what's going on. So the video is keep going very slowly. So the idea here is that at some point, either a human operator or the system itself decides that a drone should fly to a certain point and identify a certain illegal activity that is happening, or it could be a person that is in danger that needs some help. This is very recent, this smart boat that we created together with the CMMI. We have tested it at sea. And again, this is the initial steps for Cyprus for this research and innovation activity. So definitely we need your expert support and knowledge to advance. Okay, and this was Marisense. And we have papers and all that. You can check that if you are interested. And I would like to talk next about Open Sea Aquaculture. This is a new project that it's about developing a new industry in Cyprus, that of the Open Sea Aquaculture. We have aquaculture, but it's very close to the coast. And going further out in the offshore has many challenges. And that's why at some point, when people approached me to coordinate this project, I said, okay, I have nothing to do with these things. I don't know this, how to cultivate fish, for example. But I realized that there were so many issues related to IoTs and signal processing and understanding what is happening in this when you go out of line of sight. So I understood that this is a very multidisciplinary approach. So we need really all disciplines to understand how to achieve this. And definitely we would like to hear from advanced partners, and already we had a discussion yesterday on getting more information on how to accomplish these things. As you see, Cyprus here has a very large maritime area and a very small land. Therefore, it's logical to go offshore. And there is a need, of course, as many of you may know, that we need food, and a lot of food is projected to come from the sea. And Cyprus is really ideal, as Cyprus has the warmest water in the Mediterranean, and that can help for the growth of fish, faster growth of fish, and many favorable conditions. So I believe that for Cyprus, this is a very good industry to develop. but also the technologies can be transferred to all the countries of the Eastern Mediterranean and also maybe across all the Mediterranean. So that's why we place emphasis on this project. And we will take many steps. I'm not going to go through all of them, but we need a lot of, as you see here, a lot of multidisciplinarity. It's not just technology, robotics, sensing, but also all these other disciplines that we learn this is a way to learn to collaborate and understand each other. So let me go through the slides and talk. These are the partners in the project. And for those interested, they can go through these slides. So very briefly to mention is that this is a complex problem, as we first have to understand where to place these facilities. And for this, we had so many discussions that I feel that if we have an intelligent system to guide our decision, that would be even better, because you see a lot of here shipping activity, shooting ranges, tourist areas. It's very hard to find a place to place aquaculture, unless you go, of course, in the very open sea, very deep, which is very difficult to do now. We're focusing on areas from 100 meters to 200 meters. Otherwise, it becomes too costly for this stage of development. So we have to consider for these areas that we have been identifying is that the conflict with other activities, the cost to create aquaculture, what mooring and cages are suitable for aquaculture, and also to ensure the welfare of fish. So we have sustainable practices. And also we are considering not to damage the maritime environment. We are considering existing technologies, and this is one technology that we will design. It's another option. We don't know which is going to be feasible in the future, but these are different scenarios that we will develop. So this one is a catamaran style type of cage that has nets, and it can also submerge under the water and emerge when it needs to be maintained and so on. So this was OS Aqua, Open Sea Aquaculture. And slightly distorted here is I would like to tell you about the new Center of Excellence in Cyprus, the CMMI, the Cyprus Marine and Maritime Institute. This Center of Excellence has many centers. One is robotics, the other is offshore technologies and all that. And the center that I'm mostly involved in right now is the Maritime Digitalization Center that focuses on using digitalization, digital transformation to achieve optimization. For example, optimization in shipping operations linked with the new requirements for decarbonization and environmental sustainability. And many other processes need digitalization in order to become sustainable in the future. We're dealing with these different research areas, including edge processing and IoTs. And we're very linked with the robotics center, of course. We are using neural networks based on sequential Monte Carlo, and in general, methods that relate to signal processing and data science. These are the application areas that we have identified and we are interested in, and a lot of it has to do with shipping, especially in Cyprus, but also emergency response and planning, remote monitoring, and security of critical infrastructure and marine protected areas. And also, we are very interested in also education, providing education and training. We have the human resources. We're just started really. We're building a team, but we have all the things needed to create these maritime IoTs, these robotic systems, of course in collaboration with external partners. We still need a lot of more human resources and collaboration, so this is an open invitation to discuss for any type of collaboration, for writing proposals. We have even job offerings open, and we're looking for people. But also we're interested in people that look for internships and co-advising, for example, PhD students. As I said, Cyprus is a very small place, very few people, so It cannot do all these things on its own. We need to collaborate. And the material resources that we have is we're building a maritime IoT laboratory, able to build all these different types of IoTs. We're building a connectivity platform, an IT platform that is able to combine all this heterogeneous data. And we're building different IoT, both hardware and software. So the collaborating projects is Marisense and OS Aqua, and also we have a new project funded with €1 million for the digitalization of the shipping industry with Columbia Ship Management, which is a global company based in Cyprus, and leading this project and with us supporting as partners on the digitalization side. So this was the CMMI, and we can talk more about it later. And I think it would be a good time. I have about 7 more minutes before the break, so maybe it's a good time for questions. Yeah. Okay.
Thank you very much.
Thank you.
Is it working? So you cover many different topics in your presentation. Congratulations, and still you were on time. So we have time for questions, please.
One person.
Okay.
I can hear you. Yeah, I cannot answer this directly because this is the work of one of our partners. It's called Phoebe. It's a company based in Cyprus. And one of the person involved is, he did the PhD in semantics. So I can link you to this person. I'm sure that these words that you mentioned, the words that he mentions, so I think you will be able to talk and understand each other. Yes.
Okay, any more questions?
Thanks for a lot of interesting topics. So as you mentioned, in some of these, the process is very non-linear and the data is very non-linear. But then to get a good alert, you might need that non-linearity. But maybe the sensor can't handle that kind of computation, or maybe the partners are not interested in something that complex. So can you just say how you experience this?
So the question is, if I understand correctly, is
the trade-off between like non-linearities and what you can actually compute and what you can present. Mm-hmm. I think that's interesting.
Okay, that's a very interesting question that came up, and I will mention again Elias sitting at the back, who's doing his PhD in approximate computing. I think it's related to that. And the idea here is that how much information do you really need? And do you need to keep all the information from your environment, or is the human operator needing just some part of this information that they can process and understand, so that you don't do all this complicated math and all that? So it depends on what you are looking for on the different scenarios, really. If you are interested in understanding if a vehicle passing is a jet ski or a robotic vehicle and all that, you can do that on a simple Raspberry Pi, given that you have enough power. Because you can run classification algorithms on a Raspberry Pi, and you can build a simple IoT with an acoustic sensor to handle that and give you just that information. But if you want to know exactly where it's coming from, where it's going, probably, if it has bad intentions or not, or it's going to affect something, then you need something more complicated such as this. You need many sensors of the same type that's going to give you simple alerts in a certain area. But then from the simple alerts, you cannot tell the direction, for example. You don't understand the intentions. So you need to deploy a drone. Because of the limited power capacity of a drone, for example, the limited flight time, you need to direct the drone to go exactly at a place where it's needed to go. To get that information, you need to combine different data to optimize your system. So it depends really on how much computational power you have, how much sensing capabilities you have, and at the end, what is the end result, what are you trying to achieve? So all these things it's a whole spectrum of options that you may have, and we can work to find the optimal spot where you can operate in terms of that. Yeah. You can even sacrifice computational computational power to get a more inaccurate result, because just you don't need an accuracy of 1 meter, you need an accuracy of 10 meters, or 1 kilometer is enough. You cannot do all these things with these methods. The framework allows you to do that.
Thank you.
Very interesting lecture. Thank you very much. I'm interested in non-linearities. You have quite a lot of non-linearities in sensors, in actuators, everywhere. Do you have any assumption of the type of non-linearities you can deal with? Because there are some types you cannot deal.
Theoretically, you can deal with any type. So the idea here is that you are going from the state that you are trying to estimate, which can be the position of velocity or a vehicle, to the measurement space. Already, this is not linear when you are watching a vehicle passing by with an image, because you are projecting that state to the image plane. Then the uncertainties that arise there is that where is the camera facing, for example, and so on. That's already non-linear. Again, if you have an acoustic sensor, you are listening to a marine vehicle. You have to know the sampling rate, you have to know the spectrum, which you can hear, and all that. So theoretically, you can create an equation, a model, and you can add some uncertainties, and you can add a variable for an error. Now, this is physics-based. That's what I mentioned before, using physics-based, physics-informed methods, where you can build a model. And then you have to have the actual data that you use to verify the model and refine the model. I don't know if this answers your questions, but...
Thank you. Any more questions? No? Thank you.
Thank you very much.
We will have a break of 15 minutes, coffee break.